to the binomial expansion example 4. So here, for this first part, all we're asked to do is expand 1 plus x to the power of 7 as far as the term for x to the power of 4. So that's simple enough. All we've got to do is 1 plus x to the power of 7. So that's equal to 1 plus 7x plus 7, 7 minus 1, divided by 2 times 1, x squared, plus 7, 7 minus 1, 7 minus 2, over 3 times 2 times 1, x cubed, plus 7, 7 minus 1, 7 minus 2, 7 minus 3, divided by 4 times 3 times 2 times 1, x to the power of 4. So we can stop now because we've got to the x to the power of 4 term. So this is used in the alternative formula on page 4 in your booklets. So timesing these numbers together and dividing appropriately will give us our answer. So we're going to just have a 1 and then nothing's happening to this plus 7, so that's plus 7x. And then we've got 7 times 7 minus 1, which is 6. 7 times 6 will give us 42. 42 divided by 2 will give us 21. So that's plus 21x squared. Plus, and then we've got 7 times 6 times 5, which will give us 210. 210 divided by 6 will give us 35. X cubed. And then our x to the power of 4 term, we have 7 times 6 times 5 times 4, which gives us 840. 840 divided by 24 will give us 35x to the power of 4. So that is our final expansion for 1 plus x to the power of 7 up to the x to the power of 4 term. Moving on to part B. Now we are going to put 0.01 into our expansion, remembering that our expansion ended up being 1 plus 7x plus 21x squared plus 35x cubed plus 35x to the power of 4. So this was our expansion up to the x to the power of 4 term. So putting in x equals 0.01, we can find the value of 1.01 to the power of 7 correct to 5 decimal places. This is because this is the expansion of 1 plus x to the power of 7. And if we were to put 1 plus 0.01 in, which is what we've been asked to substitute in for our x to the power of 7, we're actually finding an estimation for 1.01 to the power of 7. So putting 0.01 in as x, we have 1 plus 7 times 0.01 plus 21 times 0.01 squared plus 35 times 0.01 to the power of 3 plus 35 times 0.01 to the power of 4. So doing this gives us 1 plus 0.07 plus 0.0021 plus 0.00003 435 plus 0.0000035. And adding all these together will give us 1.07213535. But remember, we're just wanting ours correct to 5 decimal places. So that's 1, 2, 3, 4, 5. So we're going to have to round up because that's a 5, which will give us the estimation 1.07214 correct to 5 decimal places. So we have our solution from part A, we have our solution to part B, and now on to part C. So we've been asked to replace x by minus 3x in the solution to part A to find an approximation for 1 minus 3x to the power of 7 up to the x to the power of 4 term. So we'll have 1 plus 7 times x, which will now be replaced with minus 3, x plus 21, lots of x squared, which will now be minus 3x all squared, plus 35, lots of minus 3x all cubed, plus 35, lots of minus 3x all to the power of 4. So, expanding out these brackets, we get 1 minus 21x plus 189x squared minus 945x cubed plus 2835 x to the power of 4. And that is our expansion for 1 minus 3x to the power of 7 up to x to the power of 4.